In this video, we're going to look at the motivation for using JPA. The problem of mapping object-oriented applications to relational database data is a long-standing well-known practice and problem. And there is a design pattern called Object Relational Mapping, otherwise known as ORM, which addresses this problem and does it very well. In 2003, Fowler, in his book, introduced the data mapper pattern, which is a form of ORM, and he said about it that it moves data between objects and a database while keeping them independent of each other. And that really is the great goal of ORM. And you can see in this diagram that you've got the database down here. You've got your domain object over here, which is in your application. And to facilitate the moving of data from database to object and from object to database, we can put the mapper in the middle. And that really is a very good summary of how JPA will work for us. So far in this module, what we have used as an architecture has been fairly good. We start off with REST controllers that call methods in services, that call methods in either a CRUD repository or just in a repository that uses JDBC template. And this repository, whichever form it is, will perform object relational mapping between the entity objects in the program and the database. These methods in the repositories will return results back to the service. And in our examples, we've been using a DTO factory to convert the entity objects to data transfer objects, and then return those DTOs back to the REST controller for processing. And this has been quite a good architecture. It separates things very nicely, and we can see from this diagram that it does look a little complex. We've got lots of classes, but actually the pattern is fairly straightforward. Now, I'm not showing the controllers that would probably be over here, because I'm just looking at how we get data between the program and the database. Here is the book service class with a reference to a book repository, a book copy repository, a copy service, and the DTO factory. And that's what these solid lines indicate, that there is a reference stored in the member variables to an object of another class. These dotted lines indicate dependency, which means that this class doesn't store references in its member variables, but its methods are going to be using objects of these classes. Now, when the book service wants to get data from the database, it will use one or more of the repositories to access the database. So here we have a copy repository, which is extending the CRUD repository for a copy object, and its key will be an integer. And those are the methods that we obtain through inheritance from the CRUD repository. You can see that we've added a couple of methods for our own purposes, and we saw that in previous videos. So here we have the repositories, one for copy, one for book, and one for book copy. And the service is going to make use of those repositories to get these entity classes that we have written that reflect the content of the tables in the database. So the separation of responsibilities is very clear. The repositories interact directly with the database, either using JDBC template, or if we're using CRUD repository, some other mechanism in the background. And they produce these entity objects, which are then passed back for use in the methods of the book service. And then the book service can use the DTO factory to convert from the entity objects to the DTO objects. And it's those DTO objects that are returned to the controller. Now, this is a good architecture. It provides a very good separation of responsibilities between the components. The developer has total control over the database access, but there is a lot of boilerplate code for ORM. Relational data from the database must be made into objects, and that means converting the relationships in the database tables that are represented with primary key and foreign key values, and convert that into object references within the objects. So a lot of the work of the boilerplate code is to contact the database, prepare statements, obtain result sets, create objects forming the object relationships and then returning those values and then closing everything down as well. A lot of boilerplate code. Even if we're using the CRUD repository, which does provide some basic ORM functionality, the developer still has got to write a lot of the boilerplate code. Here's an example. Here are 3 tables in the database. We can see the one-to-many relationship that book has with copy. We can see the one-to-many relationship that copy status has with copy. And these relationships are established with foreign keys. I've forgotten to put the FK notation in here, but these 2 attributes are foreign keys. The book ID relates to this primary key over here, and the status ID relates to the ID over here. And what we've got to do is to convert in our code, when we get this data, these relationships in terms of IDs into relationships in terms of object references. So the book has a one-to-many relationship with copy in the database, and a book has a collection of many copies. Also, the copy has a single reference to a copy status, because we can see here that a copy has one and exactly one copy status. And in our object model, we choose not to hold a collection of copy objects in copy status because there's no need for it in our application. So the conversion between relational data and object-oriented data has got to be done manually. Now, if we were to use a JPA repository instead of a CRUD repository, it would provide much more of the object relational mapping functionality that we need, including automatically creating related objects and storing references to each other. And that's what we're going to look at next. In this video, I've introduced quite a few terms that you might not have come across before, and so you would want to do some background reading about them. Take a look at ORM, maybe even do a Google search on whether ORM is a design pattern, because there are some interesting discussions on this subject, as you'd expect on the internet. And also take a look at the data mapper design pattern.